We're going to multiply our rational fractions and divide them. But I want to remind you about the rules of fractions. So when you're multiplying fractions, you're just multiplying straight across. Remember that you can cancel any common factors. That reduces to 1. So there's a little song that you can sing to help you remember this. It goes to Mary Had a Little Lamb. So it goes, multiply by factoring, top and bottom, cancel things that look alike, multiply straight across. Okay? So that can help you remember what you're supposed to do with multiplying. So you cancel any factors, you factor everything on top and bottom, there's nothing to factor here. Cancel common factors, there's nothing to cancel. Multiply straight across, so 5 times 7 and 3 times 2 gives you the 35/6. Okay? So we're going to pause on that part and look at some examples of multiplying, and then we'll go back and look at dividing. So here we have multiplying. This time we've got, instead of just rational expressions. Okay? But you're still going to do top times top over bottom times bottom, or multiply straight across, but you can still cancel any common factors. So if we look at our first example, all of these are factored. I don't have anything that I can do to factor any one of these, so all of the tops and bottoms are factored. So now I'm going to look for a common factor, so anything that's the same on top and bottom. Now remember that your factors are things that are being multiplied. So here, all of these things are being multiplied, right? The x plus 3 is being multiplied by the 5x squared, or the times by the 5 and then times by the x squared as well. And then the x minus 7 is being multiplied by the x plus 2. So the x plus 3 is the entire factor, the x minus 7 is the entire factor, and the x plus 2 is the entire factor. 5 is a factor, and x squared is a factor as well. Okay? So you have to remember that factors go with multiplying. So there's nothing that matches on top and bottom, so I'm just going to multiply straight across. So when I multiply straight across, it's conventional to put monomials first. So here, when I'm going to multiply these two, I'm going to have a monomial and a binomial, so I'm going to put the monomial first. So 5x squared times x plus 3. On the bottom, I'm going to do this times this, so x minus 7 times x plus 2. It doesn't matter which comes first, because multiplication is commutative, meaning the same forwards and backwards. So then this is my answer. We're not actually going to do any multiplying of the factors. I don't multiply them out. We just leave it like that. If we look at this next one, we've got 3 times x minus 5 times 2x to the fourth. Well, I should say it differently. 3 times x minus 5 over x cubed plus 8 times by 2x to the fourth over 9 times x minus 3. So on the top, we have no factoring we can do here. This bottom one is a sum of cubes. So hopefully you remember your sum of cubes. If not, you can look it up. You take the cube root of each one. So the cube root of x cubed is x. The cube root of 8 is 2. The same sign goes in the middle. And then you square from here to here. So that'll be x squared. You square from here to here. So plus 4. And then you multiply these two together and then change the sign. So that'll be a negative 2x. Okay. I'm aware that it looks longer, but it still is factored as opposed to not factored. Sorry. Accidental. There we go. So we have times 2x to the fourth. There's nothing I can do to factor that one. And then the bottom is already factored. So 9 times x minus 3. Okay. So now I'm going to look for common factors. So we're looking for things that match. So I've got nothing that matches, but I do have a common factor with 3 and 9. So you can still do your factors with normal numbers the same way that we've done before. So 3 and 9 have a common factor of 3. 3 goes into itself once, 3 goes into 9 3 times. I have nothing else that can be reduced, so I'm just going to multiply straight across. So this times this times this. So on top we have 2x to the fourth times x minus 5. Again, I'm just doing the monomial first. And then we've got these 3 parts. It doesn't matter which one you're writing first, second, or third. So we have x plus 2 times x. I dropped a squared somewhere in there. That should have been squared, sorry. X squared minus 2x plus 4 times by x minus 3. And then don't forget this 3. That is, normally we put our numbers first, so I'm going to put that one out in front. Okay. I double check to make sure I haven't done anything or forgotten anything. Sometimes with your numbers you'll forget something. So then this is my final answer. Okay. If we look at this next one, we're looking for anything that's the same that's on top and bottom. Now, it can be top and bottom of the same fraction or top and bottom of the two different fractions. So top, bottom, top, bottom, top, bottom, top, bottom. All of those work. Okay? So this x minus 4 cancels with this x minus 4. I like to put ones so I don't forget what I'm doing with those numbers. And then this x plus 1 can cancel with this x plus 1. And then nothing else is the same. So we're going to multiply straight across. So top times top over bottom times bottom. So we do x plus 8 times x minus 5 over x minus 6 times x plus 15. Okay. Times by 1 times 1 on the bottom, so it just remains the same, times by the 1 by 1 on top, which gives us this part. I double check. I can't do any other reducing. Now, please be very careful. 5 and 15 have common factors, but this is being subtracted from the x, and this is being added to the x, so they're not being multiplied, so I cannot reduce the 5 and 15. I also cannot reduce the 8 and the 6 for the same reason. The 8 is being added, the 6 is being subtracted. It has to be multiplying in order to reduce. Okay. Try this next one, pause the video, and then come back and see if you got it right. Okay, so we're looking for common factors. Everything's already factored, so this x plus 2 cancels with this x plus 2. Now, you may be tempted to cancel the 2x minus 3 and the 2x plus 3. They are not the same factor. This one has a subtract, this one has a plus. That's not the same thing, so I can't do anything with that. However, the 5 and the 10 have common factors, so the 10 and the 5 can be reduced. 5 goes into negative 5, negative 1 times. 5 goes into 10 twice. But I also have, since this is being multiplied, the x and the x cubed have a common factor of x. So one of these x's can cancel with one of these, and then I get an x squared. So now I have no other common factors, so I'm going to multiply straight across. So 1 times negative 1 times 2x plus 3 is negative 2x plus 3. On the bottom, we're doing 2 times x squared times 2x minus 3 times x minus 7 times 1. So we get 2x squared, 2x minus 3 times x minus 7. And we're not actually doing any of the multiplying. I could choose to distribute this negative through. Sometimes that would be a more conventional way to write it as negative 2x minus 3 over 2x squared times 2x minus 3 times x minus 7. That may be something that is more conventional to have it that way. I'm fine with either of those answers. Okay. Let's go back and take a look at dividing. So when we're dividing fractions, all we're going to do is flip the right-hand side over the bottom and then multiply. So what we can do is use this thing KFC, like Kentucky Fried Chicken, to help us remember how to divide fractions. So the K is for keep the first fraction the same. The F is flip the second one or the bottom. And then the C is change the sign from divide to multiply. Okay. So right here we have KFC, keep, flip, change. Okay. So when we're dividing, we've got this dividing. We keep the first one, we flip this second one, and then we change the sign. Keep, flip, change. So this one was kept, this one flipped, it was 7/2, now it's 2/7. It was divide, we flip it to, or we change it to multiply. Okay. So then you're doing multiplying after that. So the same process that we did where you multiply straight across. So if we look at a rational expression example, this is our original one. Now this is what we call a complex fraction, a fraction and a fraction. So if you're dividing a fraction and a fraction, you're going to take the denominator one, the one in the bottom, and flip it. So I keep this one, so that one stays the same. I flip this one, so notice the x plus 2, x plus 4 went on top, and the x minus 4, x minus 3 went to the bottom. And then we change the sign. This sign here is a divide, and we change it to multiply. Okay. So this one is partly done for us. If we look at this one, we've got x plus 5 over x minus 11 divided by 6x cubed times x plus 1 all over 3x plus 5. So we're thinking we keep, we flip this one, and then we change the sign. So this one we keep the same, We flip this one, so that means that the 3x plus 5 went on top, and the top went to the bottom. And then we change the sign to multiply. You can either use dot or an x, either one is fine. I'm going to look for common factors on top and bottom. Nothing has a common factor on top and bottom, so now I'm going to multiply straight across. So we do x plus 5 times 3x plus 5, and x minus 11 times x plus 1, and then since the 6x cubed is a monomial, I'm going to put it out in front. You can really put it anywhere, it just looks really weird if you don't put it out in front because it's conventional to have it in front. Okay? So this is my final answer. This one is a complex fraction, so we keep this one, we flip this one, and then we change the sign here. So we have, actually on these ones, instead of rewriting the whole thing, I'm just going to flip this one. Oops, that's not what I wanted either. I'm going to flip this one up here. So the x minus 3 is on top and the x plus 44 is on the bottom. And then we changed our sign to multiply. So now I'm using this times by this to help me finish my divide. So I look for common factors. There's no common factors on top and bottom. Now notice you have an x minus 3 on top and another x minus 3 on top. Please make sure when you're canceling that one's on top and one's on bottom. If they're both on top, that's not reducing to 1. If they're both on bottom, that's also not reducing to 1. One has to be on top and one has to be on bottom in order to reduce to 1. So I'm going to multiply straight across. So then this gives us x to the 5th times x minus 3 times x minus 3, or you could choose to write that as x minus 3 squared. All over, bottom times bottom, multiply straight across, so x minus 20 times x plus 44. And then I'm all done, and that's my answer. Okay. If we look at this next one, we've got one fraction here, and they're being divided. So I'm going to keep the first one, I'm going to flip this one, and then I'm going to change the sign. Okay. So I would highly suggest that in order to do this, it's annoying to rewrite the entire problem, right? So it would be annoying to do x minus 4 times x plus 1 all over x plus 3 times x plus 6, and then rewrite the flipping one, so x plus 6 times 2x plus 5 all over x plus 5 times x plus 1, and then make sure we change that from a divide to multiply, right? We can all see that's annoying. But what I'm going to suggest you do is that you cross this out and actually write the flipped version instead of just try and flip it in your mind. So that gives us x plus 6 times 2x plus 5, and then on the bottom I have x plus 5 times x plus 1, and then I'm going to change that to a multiply. Okay? And then that way, as I'm multiplying straight across, I don't accidentally screw anything up. I also need to check for common factors. So if we check for our common factors, we've got an x plus 6 that's in common, so both of those can reduce to 1. I have an x plus 1 over here that can reduce to 1. And I don't see anything else, so we're going to multiply straight across. Or if you're doing it on the one below where we rewrote it out, we've got the x plus 1s and the x plus 6. That all go to 1s. So when we multiply straight across, we've got the x minus 4. X minus 4 times 1 times the 1 times 2x plus 5. So we've got x minus 4 times 2x plus 5. On the bottom, we've got the x plus 3 times 1 times 1 times x plus 5. Oh, that was one from down there. So x plus 3 times 1 times x plus 5 times 1. So x plus 3 times x plus 5. And then I'm just going to do a double check and make sure I didn't miss any common factors when they were far apart from each other. And then this is my final answer for dividing. So remember, for dividing, you keep, flip, and then change. And then for multiplying, you can use the song. Multiply by factoring, top and bottom, cancel things that look alike, multiply straight across.